Good evening, it's Tuesday 12th of August 2014. You're here in the vBrownBag EMEA podcast webinar. This evening we are very lucky to have Mestery and Chris Wright, who are going to be talking about OpenDaylight, which is a collaborative project under the Linux Foundation related to and focused around software-defined networking, which is certainly a very hot topic at the moment. Now, before I hand over to them, quick couple of things to cover off. Just to mention that if you are going to VMworld in San Francisco, there is the VM Underground party. I believe it's on just before the event starts, or the night before. I'm not sure if there are tickets still available, but if you have a look at the professionalvmware.com website that hosts the vBrownBag blog posts, you'll see some links to VM Underground there. You'll also see some mention of the tech talks that are happening at VMworld. I believe these are also normally streamed over the internet as they happen, and there's certainly some interesting short talks to jump on there. They're normally 15 minutes long, around that sort of region, and you get quite a lot of content go in there, sometimes from speakers who haven't had their sessions accepted for VMworld, but they're still nonetheless very good sessions, very interesting topics, nice and short and sweet. There's a few representatives from the EMEA region going over there. I noticed that Julian Wood from London's going over, also Tim Gleed, Jörg Lu, Fabio Reposelli, all very good speakers with some interesting looking topics. So well worth looking into that if you're not going to VMworld, and also if you are. So without too much more procrastination, I'm going to hand over to Kyle and Chris to cover OpenDaylight. As usual, if you've got any questions, use the vBrownBag hashtag. Raise your hand, ask questions through the GoToWebinar client, and I'll see if I can get them answered for you. Kyle, Chris, over to you.
Okay, thanks, Michael. So, as was indicated, my name is Kyle Mestery. I'm currently the OpenStack Neutron PTL. I'm also involved with OpenDaylight as well. I've kind of been working in OpenDaylight for the last year or so, mostly focusing on integrating it with OpenStack Neutron and some of the issues around there. So, Chris, did you want to quickly introduce yourself too?
Sure. My name is Chris Wright, and I'm involved with the OpenDaylight project since the beginning. I helped get the project off the ground as a collaborative effort across the industry. I'm a member of the technical steering committee. I'm also on the board of directors. My day job, I'm employed by Red Hat, where my focus is on software-defined networking and network functions virtualization.
Cool. Okay, so I'll just give a quick overview for everybody here. This is kind of what we want to cover. We'll kind of walk through the hydrogen release of OpenDaylight with a little bit of what we learned during our first release. And this was the release that came out this year in February, and early February as well. So after a year of bootstrapping the project, this was the result. We'll talk a little bit about what's going on in the current Helium release. Then we'll look at a little bit beyond Helium for the planning for the release after that, and hopefully have some good discussion at the end of this as well. So let's see. So what is OpenDaylight? As was indicated by Chris as well, the key points here to know are that OpenDaylight is an open source software project, and it's kind of shepherded by the Linux Foundation. And its goal is to further the adoption and the innovation of software-defined networking as well. So at its core, OpenDaylight is a platform written in Java that allows for different northbound and southbound interfaces to be plugged in to kind of a common controller platform as well. And really, really the three tenets of this are code, acceptance, and community. As with any sort of open source project, community is kind of a key component of this. And as you'll see in some later slides, where we talk about some of the metrics around OpenDaylight with regards to contributors, lines of code, and that, OpenDaylight has a pretty thriving community as well that kind of cuts all the way across from vendors to operators to individual users. There's a large number of projects made up inside of it. So there's a lot of code here, a lot of work is being done, and ultimately, with the acceptance thing, the goal is to kind of make this kind of a broad industry project as well, so that we can get kind of acceptance on evolving SDN platforms through this as well.
Yeah, I'll just add a couple of things there, Kyle. One important reason that we highlight code is to make clear that this effort is about producing software, and that's especially important in the context of something like the OpenFlow, the ONF, which is really responsible for advocating for OpenFlow, building it as a standard protocol. It's more like a standard organization, and it's less like a code development organization. Here we wanted to take that one step further and really write code accessible to end users under an open source license and help move the entire industry forward as the platform evolves, matures, gains acceptance. We can help define sort of de facto standards for some of the layers in the stack that might be out of scope even for an organization like ONF.
No, that was actually a really great point, and I definitely think that that's an incredibly valid thing there, especially as we look at how do open source groups work compared to how standards bodies work, I think.
Right, exactly.
Okay. So Chris, did you want to cover this one, since you kind of actually started to lead down this way, I think?
Sure. So if you think about what are we up to in the OpenDaylight project? Well, on the one hand, we're building this sort of an organizational structure to support the development of the code, the generation of generating a platform that we hope gets broad acceptance. But at the core, really what we're doing is building a community of people who are focused on defining the next generation of network technology. Most of that gets captured under the term SDN, software-defined networking. Certainly that's the core tenet of OpenDaylight. We're building an open source software-defined networking platform that is, by its very definition, designed to work in a heterogeneous environment without picking a protocol winner. So there was a lot of conversation in the early days of SDN where SDN equals OpenFlow or SDN equals something else. Our project starts from a basic belief and then an architectural foundation that says there are a number of different mechanisms for communicating between a software-defined networking controller and a forwarding element or a switching device. Those protocols are varied, and we're not building a solution around a single protocol. We're building a solution that allows a collection of protocols to still present a consistent set of abstractions to applications. So that would be the common abstractions or capabilities for on the northbound side of the controller. And the northbound side of the controller is the place where applications interact with the controller, make requests of the network, ask for network resources, ask for topology information, things like that that are relevant for network resources. And an easy example of what an application might look like for an SDN controller, or for OpenDaylight specifically, could be an orchestration system that's part of a larger software-defined data center or software-defined infrastructure project like OpenStack, which we'll certainly talk about later in today's talk. Again, the basic premise is it's a network. It's managing the network. It's building that control point to offload some of the control decisions from the actual devices, the forwarding devices, help potentially make more efficient decisions at each of the forwarding junctions, that are decisions that might be hard to make with existing protocols where you have a highly distributed control plane and control information localized to each individual switching element. So hopefully that's a high-level view of what OpenDaylight is. Primarily, it's a community around SDN development.
Cool. I think that was really good. I think that was a good high-level overview. and so this next slide actually kind of goes into a little bit more detail around the previous slide visually to kind of show the actual platform, the actual modular pieces of the code that we're looking at doing as well. So really, this slide tries to divide things up from network applications, orchestration interfaces, things like that on the top, all the way down to the actual data plane elements on the bottom, which are outside of the context of OpenDaylight, but are ultimately what OpenDaylight will be programming forwarding decisions into. If you look at this, so you can see that there's different things in here around different abstraction layers, different REST interfaces, and things like that. This is kind of good visual representation of that.
Yeah, and you can see on the top we have those REST APIs. That's a perfect place for an application to integrate with OpenDaylight, and you'll see later that that is an integration point for OpenDaylight integrating with OpenStack. You see in the core, we do want to create something that has a platform filled with services. So you could almost think of this like an operating system, and the REST APIs are sort of analogous to system calls into the operating system. The controller platform is analogous to that core kernel of the operating system. And then those southbound interfaces are sort of analogous to device drivers. Maybe you have a common abstraction around I/O devices or a common abstraction around file systems. At the very bottom, you have something that knows how to speak the specifics of that I/O device or that file system, or in this case, the specific protocol to program a particular forwarding element in the network.
So continuing on here, this slide is really talking about showing how the Linux Foundation has kind of set the OpenDaylight project up with regards to the vendor participation here as well. Not just vendors, but maybe corporate levels of sponsorship and things like that. So similar to other projects like OpenStack and such, there's different levels. You can kind of see from a corporate perspective, there's a broad swath of participants here that are all members at varying levels of this project at this point. One thing this slide doesn't really capture is the community level and perhaps the non-corporate level of an involvement, which certainly there is some of that, but this slide was mostly meant to capture kind of at a higher level to show the participation across vendors in OpenDaylight and how all of these companies are kind of working together on this project as well.
Yeah, I like to refer to it as a veritable who's who of the networking industry. And like Kyle said, this is really about who's helping fund the organizational structure around the project, and certainly who's employing some of the developers on the project.
Okay, so let's see. So let's look at this simultaneous release. So the simultaneous release, we had referenced or alluded to earlier in the discussion that OpenDaylight is made up of many small projects itself that are under the OpenDaylight umbrella. And the way that the release worked was that a simultaneous release was made where all of the projects that wanted to be a part of the ultimate simultaneous release were signed up for it. And they had to, there was a whole process along the way of getting to this simultaneous release in February of this year. At this point, this is kind of what it is. And so ultimately the hydrogen release was going to be 20 plus projects in bootstrap or incubation state. They were going to be bringing these components all together. The original planned release date was December 12th of 2013. along the way to doing this simultaneous release, in various discussions on the mailing list and at the weekly meetings, we came up with, having all of these 20+ projects in the simultaneous release was a bit kind of like having a pile of Legos almost. So we came up with the idea of targeting kind of 3 different specific use cases for an SDN controller like OpenDaylight. And they were kind of a base edition, and then a virtualization edition, and a service provider edition, kind of looking at these 3 use cases as at least something that we would make releases targeted for this as well. And it's worth noting here that the virtualization edition was the one that would provide the OpenStack Neutron integration as well. Okay, so this slide kind of says great plans and the best laid plans and everything, right? Well, we learned a lot of things amongst that first simultaneous release, but the reality was we ended up slipping it almost 2 months into February of 2014. And ultimately there's many reasons for that. I mean, you can certainly look at trying to do a release of this magnitude, not only a release, but the first release of a software project, an open source project of this magnitude near the holidays certainly proved challenging. There's a lot of downtime around the holidays as well. We tried to get the release to be as stable and bug-free, and so there was a lot of fixing of issues towards the end. I know on the OpenStack side of things, the integration side, we worked really hard to get that integration all done so that we could integrate with OpenStack as well. So there was really a lot of balls being juggled in the air towards the end of this, and that's kind of the result. Was this got moved a little. So Chris, do you want to talk to this slide?
Yeah, you bet. So, what was the hydrogen release? What was in there? As Kyle mentioned, it was a collection of a number of projects. We have a list here of the names of each of the projects, and I'll go through and try to give you some sense of what each of these individual projects do. The kind of the core or a core and prominent project of the entire OpenDaylight umbrella or effort is the controller project. The controller project on that architectural diagram that showed things like network services, on top was the REST APIs, below was a service abstraction layer, and below southbound. The controller is that kind of core middle box in that picture. It has some of the key services, so that the controller is a place where you collect topology information, as an example, or an inventory of devices that are being managed by the controller. In addition, the controller has some of an early implementation of some of the original southbound protocols. So we actually have some very basic OpenFlow protocol component within the controller itself, so that ideally it works almost as a standalone component. So this is as Kyle mentioned earlier, this is a Java platform. The controller makes heavy use of a technology called OSGI. Most of the components of the controller are OSGI bundles. And over time, our expectation is actually that the controller project will slowly break apart into collections of smaller projects, because it really started off sort of as the catch-all for things that didn't have another home. And ultimately, to really be a great modular project, we would like to allow each of the individual services, for example, to develop on their own without requiring core reviewer time from somebody who's responsible for something completely different. It just happens to be in the same Git repository. We have a couple of sort of virtualization-specific components of the hydrogen release. You see the next item on the list here is VTN, stands for Virtual Tenant Network. Below that is OpenDove, and then to the right of OpenDove is OVSDB. Each of those provides some mechanism for managing the network virtualization requirements that come with some kind of a virtual data center infrastructure. VTN is a project that originally came from NEC, where they had written this same functionality to work on their SDN controller called the Programmable Flow Controller. What VTN does is it allows integration with some kind of an orchestration system like OpenStack, CloudStack, whatever, to inform the tenant isolation requirements of the orchestration system to the network layer. The VTN project translates all of those requests into OpenFlow specific protocol commands to physical switches and uses 100% flow programming as a mechanism for isolating tenants. So the typical issues that you hit with virtualization, especially when you are using isolation based on VLANs, is you either run out of VLANs completely, or if you're not exhausting the VLAN limit, you're certainly creating an interconnected mesh of layer 2 segments that can create massive broadcast, a massive broadcast domain across your entire data center, which people went to great lengths to use VLANs to actually isolate broadcast domains from one another. And network virtualization can often undo the great work that you did as a network engineer to isolate those different segments. VTN approaches that problem from an OpenFlow perspective and programs each of the individual physical devices to direct traffic through from port to port and link to link based on 100% flow matching from an OpenFlow perspective. OpenDove takes a different approach, an approach for the VMware folks that are familiar with NSX, an approach that's more similar to NSX. It's the Dove portion of OpenDove stands for Distributed Overlay Virtual Ethernet, so it's an overlay technology. So here you're not actually managing any physical infrastructure. You're exclusively focused on the edge virtual switches in each hypervisor node, where the virtual switch in this case is an OpenVSwitch instance typically running on a compute node that is Linux and KVM powered, and creating a VXLAN overlay topology. OpenDove is the project that manages the tunnel endpoints. It manages doing intelligent things with packets like our packets, DHCP packets, and it has the mapping information between the actual Ethernet MAC address of a virtual machine and the endpoint IP address of the host that virtual machine is sitting on, so that you can create a tunnel between the two endpoints that need to talk to one another. Interestingly enough, OVSDB is actually a similar project to OpenDove. The main difference is OVSDB is very focused on using OpenVSwitch and the existing OpenVSwitch protocol command channels. So the two protocol command channels for an OpenVSwitch instance are one, OpenFlow, and the other, the OVSDB protocol. The OVSDB protocol, or the OVSDB project, also has a very specific focus of integrating with OpenStack. So there is a neutron-specific component to the OVSDB project. It's managing tenant isolation in a number of ways, each of which that can be expressed starting from OpenStack. And those are either traditional sort of legacy VLAN isolation or using some tunneling technique, and OVSDB will support GRE as well as VXLAN. The Affinity Management Service is a service that allows a user, it presents an API that allows a user to create something known as affinities between network endpoints, essentially. And in this case, you could imagine a virtual machine or an application that spans multiple virtual machines. In order for that application to function properly, it may need, for example, a high bandwidth or low latency link connecting the two endpoints of the application. You could express that kind of sort of quality of service requirement as an affinity. The affinity service then can map that down to actual flows in the network so that you could ensure that the placement of your workload complies with the affinity requirements expressed through the affinity service. The Lisp mapping service is really just what it says. It's a project that implements the Lisp protocol, and it implements the mapping functionality of the Lisp protocol. So Lisp is a mechanism that allows you to separate the notion of your IP address as your physical location, which is really how networking works. Is essentially you've got some notion of routing tables and subnets that ultimately are directing you to a physical location. It allows you to separate that notion of your IP address being a physical point in the network to being sort of a virtual point in your network, and there's a protocol for translating at all the intermediate hops, kind of where are you really. And I always make this project analogous to your cell phone, which you have a phone number that's associated with your cell phone, but you also have a mechanism for communicating sort of internally within the network where you are in the network. So when someone dials you, they get your phone regardless of where you physically are. This is managing that mapping and can be useful in a number of different virtualization type settings. Yang tools is another core component, something that we haven't really touched on quite yet in this presentation. But the controller has a set of abstractions that sit on top, the northbound REST APIs. The Yang tools is a project focused on taking Yang models, and Yang is an IETF specified modeling language. Takes Yang models, and essentially it's a set of compiler tools to turn those Yang models into a combination of Java classes and REST endpoints associated with those Java classes. So you can model a network, or you could model a service in Yang. You use the Yang tool compiler toolchain to generate all of the code associated with that model, and now you have both the northbound APIs, through to some of the southbound components where you would actually then plug in a southbound interface to connect that top to bottom call flow from the northbound APIs expressed through REST-conf based on Yang down to the southbound that's actually going to create a protocol command to an individual device element. And one common mechanism for the use of Yang tools is in conjunction with netconf. So if you think of historically in the data center in your network, you've got a bunch of network devices that are managed with SNMP, the protocol, and MIBs as a definition, a language for defining the interaction, the attributes of that device. Yang and netconf are sort of a more modern implementation of that same set of requirements. And going forward, the expectation is that Yang and a model-driven approach will be more and more central to the OpenDaylight controller. Defense for All is actually an application, primarily an application that sits on top of the OpenDaylight SDN controller, and it is a distributed denial of service application. So here it's interacting with some of the core services in the controller, looking for what it's going to identify as a collection of malicious flows that are coming in from a variety of sources and targeting a single endpoint. Using the information stored in the controller, it can detect what it believes to be something that looks like a distributed denial of service attack, and then redirect those flows to some kind of a detection system or black hole them, or however it's configured to manage those flows. The BGP-LS project, PSEP project, or BGP-PSEP project, is a project that's focused on a portion of the BGP protocol, and specifically PSEP, or path computation. So here we have the ability to not speak the entire BGP protocol, but be like a reflector, and then with the information with the information associated with BGP and the different routes through the network, use the PSEP protocol to define an engineered path through your data center. So this is kind of a more common service provider type set of protocols, maybe less common in the enterprise data center. And as you'll see later, we sort of lumped it that way in our different release vehicles. This particular project is likely to kind of grow and slowly split apart. We're starting to see more interest in just BGP, and it might make sense to have PCEP as a separate project. But initially, they came together as they're solving one problem in concert with one another. We have two OpenFlow projects. I did mention there's an OpenFlow implementation in the controller. That's completely based on an existing project called OpenFlowJ, Java implementation of OpenFlow. That's limited to the 1.0 protocol specification. For a number of kind of technical reasons, we decided to start over from scratch with a new protocol library that's OpenFlow centric and capable of supporting multiple revisions of the specification. That is the OpenFlow protocol project. So it's sort of internally called OpenFlow Java, so it's OpenFlowJ. And that protocol library is then bundled with a southbound plugin, the OpenFlow southbound plugin, to produce a model-driven OpenFlow implementation that's both 1.0 and 1.3. And we have integration with that in projects like OVSDB, where you need to speak both OVSDB to the switch as a configuration language and OpenFlow as a flow table programming language, and OVSDB specifically can benefit from some of the 1.3 protocol improvements. I already covered OVSDB. SNMP for SDN is an interesting project. It came from really a university trying to scratch their own itch, where they have a heterogeneous collection of hardware. None of it is OpenFlow compatible or controllable. So they've written a southbound plugin that allows you to do device management via SNMP. So taking traditional SNMP commands and giving the SDN controller the ability to issue those commands through to the device and manage it as if it's sort of an OpenFlow managed device. And there's potentially a little more in there as well, where in some cases you might have to essentially log into the device and issue some CLI commands. The last two projects were in the list of development during the Hydrogen release, although they didn't make the cut, so we didn't actually release those as part of Hydrogen.
Cool. That was an exhaustive list, Chris. Thanks for covering all those.
Yeah, you bet. Give your voice a break.
Thank you. So let's see. The next couple of slides walk through visually again kind of what Chris just talked about, and show kind of an architectural building block piece of how all of these different bundles fit in, and specifically what the overall Hydrogen release looks like, and then also what the base virtualization and service provider editions look like. So I think we can kind of walk through these. We'll kind of go through these a little bit quickly here. This is what the overall project looks like when we released, with all of the different OSGI bundles in there. You can see some things sitting on top as well that consumed the APIs, the REST APIs. You can see the southbound interfaces and protocol plugins and things like that as well. If we go to the next slide, you can see what a stripped-down version of the base edition looks like. So the base edition removes a bunch of bundles and kind of packages together, what would be considered base network service functions inside the controller platform, as well as underneath. It packages together the OpenFlow southbound plugins and the netconf southbound plugins as well. So this edition was more for, and Chris, correct me if I'm wrong, but I believe this edition was for experimenters, maybe researchers, those types of things who wanted a kind of a stripped-down controller interface that could speak OpenFlow and netconf on the southbound side, and could be orchestrated on the northbound through the REST APIs into OpenDaylight.
That's right, Kyle. And the other thing that the base edition, or two other things that the base edition is useful for, one is by its name, you might infer it's the base for the other editions, but also it's it's the kind of simplest stripped down end-to-end functional assembly of the various pieces in the project that allow us to do integration testing. So we use this base edition as a, you could connect this to a mininet instance of a virtualized network topology and validate that all of your flow updates are actually propagated out to the network. So it's a nice simple tool both for users just to get a feel for the project, but also for automated integration testing.
Excellent. So we'll jump to the next edition, which, as Chris said, the service provider edition kind of builds on top of the base edition. And you can see that on the service provider edition, kind of what we've added is, we've added the DDoS protection on the top. We've also added inside the core controller functionality the Affinity plugin and the Lisp service integration. And then on the southbound, we've added the Lisp protocol, the BGPLS, the PSEP, and SNMP integration as well. And taking this one step further to the virtualization edition, remember, this is going to build off of the base edition, not the service provider edition. So you can see that this, instead of, if you look at the service provider edition having Affinity and Lisp, this has the Affinity service, but in place of Lisp, it has the OpenStack service, the VTN manager, the Dove manager. It also adds, importantly, the OBSDB southbound plugin and protocol integration there, and then it, of course, adds the ability on the northbound side for the OpenStack and the VTN coordinator as well. And this virtualization edition is the edition that as a user, someone who wanted to experiment with this release of OpenDaylight, this is the version that you would use to integrate with OpenStack Neutron as well.
Yeah, one thing to note, this was our first attempt at taking a collection of modules or sort of a toolbox of tools and turning it into something that's easy to use as an end user without having to understand the connected relationships between all those tools. Quite honestly, we got it wrong, and it turns out that service providers care about virtualization, or virtualization folks care about Lisp, or it's our sort of lines in the sand were drawn somewhat arbitrarily, and some of our users have expressed that to us. So going forward, we're working towards what we're calling a feature-based mechanism for users of the SDN controller to be able to identify which features they care about and have that assembled as a functional unit without having to create these individual additions that may or may not fit your use case or your needs.
Yeah, that's the problem with trying to draw those lines in the sand for these types of things. It's hard to get them, drawn correctly, I think, but it's good. But I mean, and that all goes back to, this was the first release of a project of this size with a group that was, learning on the fly as they went, and so I think a lot of good things were learned with this release, as we'll see in a future section of the presentation here, kind of what the lessons were learned and how we're applying those to the future releases. So now we'll briefly kind of talk about the OpenStack integration, and this was something that we've kind of talked a bit about for a while now, and like I said, it's released already. It's released, and the nice thing is that you can pull this down. There's plenty of websites with tutorials and blogs where people have written about how to try this out as well. The gist of how this works here is that OpenDaylight will expose the single common OpenStack service northbound. And what we've done is we've kind of matched the OpenStack Neutron v2 API precisely exactly how it is as well. So we have a Neutron, on the Neutron side, we have an ML2 mechanism driver, an OpenDaylight one, which is actually, for the most part, a thin proxy interface which will proxy API calls across from OpenStack into OpenDaylight, so that OpenDaylight will be aware of all of the different entities being created, whether they're ports, subnets, routers, networks, things like that as well. And so then these actually get proxied across into the OpenDaylight Neutron service as well. And then the way that works is that kind of serves as a database for these API calls and for the objects and entities that are created. And other things such as the VTN provider, the DUB provider, or the OBSDB provider, they can all register for these events as well, so then they can consume these APIs. And that's kind of how this works. And so the nice advantages of this, it's fairly obvious right away that this kind of simplifies the OpenStack plugin. The OpenDaylight mechanism driver is somewhere around 400 to 500 lines of code, so it's pretty tight and contained. It also pushes the complexity over to OpenDaylight. So there's that as well. So, Chris, did you have anything you wanted to say on this slide as well before we go to the next one? Or?
No, you got it, Kyle.
Okay. So this slide is slightly dated, but well, kind of. But the good news is that, like I said, the ML2 driver is available. It was in the Icehouse release, so the code and the Icehouse release of OpenStack was the last release, which came out in April. So this mechanism driver was able to merge right at the end of the Icehouse cutoff, and so it made it upstream. Currently, that version, along with the Hydrogen version of OpenDaylight, supports VXLAN and GRE tunnel networks. There's also DevStack support as well, and what's interesting about the DevStack support that was merged in the Icehouse timeframe was if you're using DevStack, which is what a lot of people use to give this a try initially, certainly it's what the developers of OpenStack use to kind of do a little bit more than functional or unit testing of their code to actually try things out in practice. OpenDaylight actually runs as a top-level service in DevStack, which is actually a pretty interesting thing there. Like I said, so initially this was all done with an ML2 plugin. So this still makes use of the Neutron DHCP and the L3 agents. So that, so this was it was a good first start for us to get this work across, but it's still kind of all of the limitations around the Neutron DHCP and L3 agents that you may have with the standard ML2 plus OVS agent or Linux Bridge agent. You'll still have some of those issues here as well because of the DHCP and the L3 agent. So kind of segues us into the next step. So what are we planning for Helium and Juno? So, on the OpenStack side, there hasn't been a lot of work because the plugin itself, the driver on the OpenStack side was so thin. We've added some delete support for some different things. I've seen some people pushing some patches for that. But most importantly, we've had some people looking at how to do security groups and how to do, whoops, sorry about that. Let me just get rid of those. Go back to full screen. There we go. So most of all, we've had people looking at security groups and L3 routing as well, how to do distributed virtual routing. Those are things that people are working on now. It's unclear if those will land in the Helium release at this point or not, but there's certainly areas of where we'd like to see some improvement because the security group support would mean that we could try to do as much of the security groups enforcement using pure OpenFlow rules plus maybe possibly looking at extensions as well for that. And the L3 routing, that would be really nice to do because in the Juno release with the standard OVS agent running in with the ML2 driver, we actually merged functionality to do distributed virtual routing there. So we can look at doing the same thing with OpenDaylight and in fact use possibly even use a similar API as well to handle that as well. And then of course, we're looking at doing additional kind of small refinements and bug fixes as we go along, cleaning up logging, things like that.
Yeah, if you look at it from a high-level point of view, we started with L2, which is the primitive for Neutron, and we're adding higher-level services. So we want to get L3 functional, whether it's done through the agent and DVR or whether we can do pure flow-based L3 is a work in progress, and the team hasn't quite concluded which way is going to be functional for the Helium release. But then security groups or firewall as a service or load balancer as a service, these higher level services are all kind of the next steps that we'll be tackling as from OpenDaylight, from the OVSDB project, and integrating with OpenStack.
Perfect. Thanks, Chris. So this slide is also a little bit out of date. You can see it only goes up to February of this year, but the point of this is to kind of show the growth in the number of proposed projects and projects that are accepted into incubation, projects that are part of the releases and things like that. So I think, Chris, we had talked out of those 7 new project proposals, right? Did most of those, or maybe 5 of those actually were accepted at this point, right? So this.
Yeah, I think even ultimately more than that have been accepted, although a couple of those ended up, the project proposers decided to postpone their proposal till a later date. But we've got a whole set of new projects for the Helium release. And really, like Kyle said, the point is to show that this is an umbrella project that continues to grow. It grows new projects. We're growing contributors. We're growing in terms of the code base, et cetera.
Excellent. So let's see. So this was a slide which we had looked at as well, or we had alluded to before. So this kind of talks about code volume. And this slide and the next one, like where are we at? This slide in particular looks at looking at OLO to see across projects where we are. You can see Java is used by a large number of projects on OLO as well, and of course OpenDaylight is written in Java. The interesting slide, I think, is this slide here that kind of looks at a comparison of where does OpenDaylight rank in kind of some other projects which are around networking orchestration or perhaps SDN controllers, things like that, or just SDN in general. And I think it's interesting to note here that you can kind of look by lines of code, which is the first column, and contributors. You can kind of note here that OpenDaylight lines up somewhat closely to CloudStack here with both lines of code and contributors. It's a little bit less, but it has quite a bit more code than Floodlight, for example, contributors as well. Certainly contributor-wise, it's kind of behind OpenStack, which is a much larger project in terms of code there, and certainly by contributors as well. But the good thing is that I think these numbers are growing as well, and we're getting more contributors and things like that. So this is always encouraging as well. Let's see. So this slide is, this kind of goes back to where we talked about who's kind of funding this as well. Apologies, I'm going to clear another calendar invite. There we go. So this goes back to who's funding this, from the foundation perspective, and how are we gaining people in this. This is kind of a nice curve that goes upward here and things like that. So I think this is a pretty good, this is a pretty nice thing to see that we're still getting new people joining, new people contributing resources in terms of coders, in terms of projects and things like that. So this is definitely nice to see with a project like this. So we've kind of gone through, actually it's taken us almost 50 minutes to kind of go through the what is hydrogen and where we're at. So I think at this point we'll kind of walk through and I'll walk through these next couple of slides really quick on kind of learning where this is from, what we've learned, and then we'll jump into Helium there. So what this, and I'll make a note that these slides, and in particular these 3, kind of came from Dave Meyer, who's the head of the TSC for OpenDaylight and works at Brocade as well. And Dave's written a great blog post summarizing his thoughts on this, and I really agree with kind of where he's at. And the key learning for him, and that a lot of people kind of would agree with, is open source is a new way to develop non-differentiated plumbing as well. And a lot of this kind of goes back to, we had alluded to earlier in the conversation around how are these open source projects different from standards organizations. And really, code is the difference, because at the end of the day, a lot of the times the standards organizations are producing documents with standards, and a lot of the times what happens with the open source project is they end up producing standards through code rather than through documents as well. Another interesting thing is this engineering systems are as important. Speaking of engineering systems, this is what are the tools you use to build the project, and how scalable is that? How automated is it? How much can you remove people from having to be involved there so that you can automate things and scale the project? I think a classic example there is if you look at what OpenStack does with their whole CI infrastructure. I think at any given time they have around 800 to 900 VMs which are running various jobs on all of the patches that are being merged into OpenStack, and that's across multiple public clouds and multiple regions in public clouds as well. So, you know, OpenDaylight is moving in that direction. They're moving their infrastructure in that direction, so I think that's a good thing as well. You know, and Dave's point in one of his articles was sometimes it's not what you build, you know, that maybe isn't as important as how you build it, because, you know, the engineering artifacts, what you're producing, maybe that's no longer the source of sustainable advantage, right? And certainly I encourage you to read Dave's blog, which is referenced there in those slides, you know, for much more thoughts on that as well. But, you know, his ultimate conclusion was, you know, open source has transformed the good, cheap, fast development cycle, I think. You can build good or cheap from fast by using open source development methodologies, and you can leverage the open source communities. It's kind of like leveraged investment here. So anyways, let's move on to this. Let's move on in the agenda here to Introduction to Helium. Chris, do you want to take a couple slides here?
Sure. So Helium, the naming's probably obvious already. We had a discussion early on about how will we name our projects, and we decided on using the periodic table. One interesting reason why is it translates nicely to a wide variety of languages, and you don't end up having a phrase that has a bad connotation in some language that you didn't anticipate. So we're on to the Helium release. And I don't know if I can do slides, so you'll have to advance the slides, I think.
There we go. Did it take?
Yeah, there we go.
Okay, cool.
So this is sort of an eye chart. The purpose is not to make you fluent in our release plan as much as just show you that there's a general structure for how we do releases. The structure is we build a series of milestone releases, and those milestones have different requirements. This is for, again, a large variety of projects, each of which are kind of doing their own, have their own source code repository and doing their own internal development. And these milestones are points where we want to be sure that we understand things like what are the dependencies between projects. If project 1 has a functional dependent on project 2, and project 2 is for whatever reason slow to produce that dependency, that's something that we need to see in this organized simultaneous release effort. And there's a set of different milestones at each, or different points at each of the milestones. Things like when do we actually do a final freeze of the APIs? When do we do a final freeze of the code? What, for documentation perspective, we do string freezes so we can actually produce internationalized strings. These are all the different milestones, and then we go to short session of release candidates. All along the way, we're doing continuous integration and validation of any change that's coming into the system. But as we get further along, we start doing more and more systems integration, and the release candidates get run through the most comprehensive set of tests. And then ultimately, we have a final release, and we make that release, and then we follow that release with a set of stability releases. Things when users report bugs to the system that are kind of critical bugs, not just any old bug, but something that could create something like corrupted state in your network, or crash the controller or something like that. Those are the kind of fixes that we want to target for the stable releases, and those stable releases will continue on a parallel path to the new development on the next release.
This is a pretty epic slide.
Yeah. So here we have another list of projects. And so this, if you take what we had in Hydrogen, that long list of projects that I walked you through, these are the new projects. So we take Hydrogen and then we add a set of new projects. So again, I'll try to walk you through each of these projects. The group-based policy project is a project that whose goal is to sort of change the way we consider doing network management. What are the base abstractions that we present to a user for managing their network? The group-based policy project is showing abstractions in terms of basic functional groupings of applications. So as an example, you could group your web tier together, and you could group your application tier together, and then you could make an association between those two tiers, perhaps saying, identifying the TCP port that they need to use to communicate with one another. Not really needing to go any further in terms of sort of low-level network engineering descriptions, where the way this might be realized in a typical data center might look like two separate subnets and some firewall rules between the two separate subnets enforced in an intermediate router. Group-based policies' goal is to abstract some of that, potentially allow the network fabric to use different mechanisms to enforce that policy, but really placing the policy as the first and foremost abstraction that a user interacts with. This is especially important from an application developer perspective, where your goal is to write your app and deploy your app. Your goal was never to become a network engineer, and when the network resource allocation portion of launching your application workload includes understanding the relationships of ports and subnets and routers that are more network engineering type concepts. That's potentially a barrier to adoption, a barrier to you getting your work done. Packet cable or PCMM manager, this is something that came from the cable industry, where they're essentially building what looks very similar to an SDN controller using OpenFlow to manage a forwarding device, but instead they're using the SDN controller with a different protocol, the PCMM defined protocols to manage cable devices. So similar concept to managing a traditional forwarding device, but here you're talking about a cable device that's part of your connection to your home connection to the internet, for example. The SDNI application is essentially an attempt to build a communication link between two separate instances of the SDN controller. And really the purpose here is an SDN controller for OpenDaylight, and it's common across the industry, is typically a distributed application. So you can scale that controller by adding additional nodes as it's controlling more and more devices. At some point, the synchronization overhead of keeping the distributed state synchronized across each of the control points in that sort of logically centralized controller starts to outweigh the effects of adding more and more nodes to the distributed system. So SDNI really is about federation. How can you take two separate logical instances of the controller and federate those two and only share critical information, which might be a little higher level and not all the low-level granular flow programming details of each individual device, for example. There's a new plugin that helps us connect to the OpenContrail platform, which is kind of interestingly enough another SDN controller. So here we have OpenDaylight presenting a common set of APIs that are essentially translated into OpenContrail specific APIs, and then OpenContrail would be responsible for managing the actual flow forwarding in your network. There's an L2 switch application, which is taking what we had in the controller, which was a quote-unquote sample, and making that slightly more robust and actually functional so that you could use this application to behave like a learning layer 2 switch. The SNBI application or project is building off of some standardized mechanism for doing secure network device bootstrapping. So it's primarily about the certificate infrastructure for authenticating a particular device to your network, so that as a controller, you're actually controlling a device that is a known to be valid device in your data center. AAA service. AAA is authentication, authorization, and accounting, sometimes also considered auditing. But this is really how do you authenticate and authorize users of the platform, and then create some kind of an auditing trail or accounting trail for all of the actions they took through the system. There's a new interesting project called the ODL Toolkit, and that ODL is OpenDaylight. The Toolkit project is based on our experience of interacting with developers, not developers of the core controller, but developers of applications that would sit on top of the controller. Our experience was, or the feedback we got from those developers is, your platform is too hard to write code for. There's too much boilerplate stuff that we need to kind of cut and paste that we don't really want to have to understand or deal with, when our real goal is to write, for example, a layer 2 learning switch or something. So this toolkit project uses, since this is primarily a Java project, and our build system is built from Maven. Maven has a notion of something called archetypes. Archetypes build sort of template projects that automatically fill out all that boilerplate stuff. So you can create you can bootstrap a project or an application on top of the controller quite quickly and go right into your specific application-specific logic without having to get mired down in the details of how do you interface with the controller. The dynamic resource reservation project is an attempt to recognize when you have a resource or a service or a network function in your data center that needs to essentially react to the workload applied to your infrastructure. So as an example, maybe you have a distributed firewall, and part of launching a new virtual machine might include, I need to launch a new firewall instance on the same host where that virtual machine is. The Dynamic Resource Reservation project is trying to make that mapping and manage those connections between the network service and the application workload. The TTP project, I forget, it's table typed something, I'm sorry, I forget the acronym, but it's very specific to OpenFlow. One of the challenges with an OpenFlow-based controller environment is the OpenFlow protocol has gone through many revisions, and in the newer revisions, like 1.3, for example, there are a large number of optional features. So you have to do a lot of low-level feature negotiation to recognize what the actual device is capable of. And instead of doing that low-level feature negotiation, the TTP project, which is really coming directly from a working group in ONF, the TTP project is recognizing that there's a common collection of features of optional features in OpenFlow that equal a basic functionality. So if you enable feature 1, feature 2, feature 3 together, now you can do offloaded dynamic tunnel provisioning or something like that. So it's trying to raise that feature negotiation to one higher level of abstraction so that it's a little simpler for the SDN controller to figure out what a device is capable of. OpFlex is a protocol specified in a draft in the IETF that is in association with that first project I mentioned, group-based policy, where you're specifying this high-level policy. How do you want your network applications to utilize resources from your network? OpFlex is the communication protocol that allows a switch and a policy profile, a policy database to communicate, to do a policy exchange. So one possible way to use group-based policy is you specify a policy, and ultimately within the controller, you render that policy to specific flow table updates, and then you issue flow table updates to a specific device. Another way to do that, which might enable further optimizations, would be rather than sort of push these low-level flow table program updates, flow table updates to the device, just push the high-level policy across the device, and maybe it has an optimized way of specifying how to enforce that policy. The root parent project is purely internal to the build system, and it's a Maven-specific project that allows us to have a single Maven POM file or root POM file for all of the projects. So we, again, simplifying the development process for new projects in the OpenDaylight umbrella project. And we have a documentation project, which is self-evident, and we're really that's an area in open source where often people are more excited about writing code. Documentation is critical to explaining to users how to use this code that you've been developing. So luckily, we've had a solid interest in building a documentation project, people who have passion around writing technical docs. And this will be, we sort of kick-started it a little bit in Hydrogen, but Helium will really be the first release where we have this concerted effort around documentation. So that was the exhaustive list of what's coming new in Helium.
Thanks, Chris. That was pretty epic. So let's now, we just finished talking about what's coming in Helium. So let's go past Helium and think, what's past that even. So a few technical details, and some of this is things that we haven't totally covered. These are kind of high-level, perhaps architectural things with OpenDaylight that the community is already kind of engaging in and looking past Helium and saying how, when will these land, when is it appropriate to move these things? And these are things like the model-driven cell or the MD cell, which, is a very low-level detail, but you'll remember there was another slide that mentioned the AD cell. So this isn't kind of maybe not an evolution, but a change in how the service abstraction layer works. How do we do stable releases? Chris had mentioned this before, but healthy projects, healthy open source projects usually have a stable team, and the stable release ends up being very important because a lot of the times after the release, you'll find a lot of bugs, and you'll want to backport those fixes and get them out to your stable users. Certainly for distributions, this is a really important channel for them to be able to get the fixes out to the packagers or to the people that are packaging and distributing this as well. And, simultaneous release cadence, how do we deal with that going forward? Future release vehicles. We mentioned we used OSGI. There's been some discussion and some work around looking at Carafe as a possible container for that as well. And where do we go forward with that with regards to OSGI or Carafe? And certainly there's a breadth of quasi non-technical issues around things like project governance, API stabilization, things like this. So these are all healthy things for an open source community such as OpenDaylight to be discussing.
Yeah, I'll just add a little bit here, Kyle. Some interesting things. These are part of our learning process. So open source is about openness and transparency. We don't hide the fact that we're learning as we go, and we've learned that the MD SAL represents cool technology, but it's difficult for projects to integrate with. So there's a team that's spun up around identifying the difficulties of working with the existing MD SAL, which is, from this point of view, we're talking very much an internal implementation detail, but the overall focus is how can we make it better. Stable releases, we actually realized that we didn't communicate well to projects that were in the Hydrogen release, that part of their agreement to being in a release is issuing stable updates. We actually had one project that doesn't have resources allocated to updating their project, and they don't have any bugs filed against it. So we found ourselves in this quandary: do we release a stable update without this project, or do we release a stable update with that project as it was in the original release without having gone through exhaustive testing? And the really interesting one, I think, is this Carafe piece, where we've made significant strides towards building better modularity into the system. We're already using OSGI as a basic system for managing modularity and how services can come and go from the runtime environment. Carafe takes it one step further and it enables us to do this feature-based enablement of services, and potentially changes completely how we do our releases. And we're deep in those discussions, and there's a bunch of really cool ideas of how we'll release in the future based on Carafe. And something that, I'm coming from a Linux distribution point of view, where we have a lot of services that are modular and configurable, and you're used to sort of editing a configuration file to specify how you want your service to launch and then launching the service. This takes us a step down that type of path, where rather than having to grab a pre-bundled or a pre-combined set of OSGI bundles, you can specify exactly what you want and launch that directly. And clearly that has some implications on the testing side. So a lot of interesting stuff that we're grappling with. And that last one that's really, it's an interesting thing to consider in an open source project. Where do you get authority to make sort of architectural changes to a project? In some cases, you have kind of a top-down approach where there's a single person who wrote the core of the original code and is essentially the maintainer, the benevolent dictator for life, and they're usually responsible for most key architectural decisions. In a project like this, where we have a collection of people building consensus, we don't have that benevolent dictator for life. We do have a technical steering committee, and there's some back and forth, and at that level of should the steering committee provide more architectural influence, or should we really allow that to come bottom up from the individual projects? So really some interesting stuff that we're learning as we go in this project. And I don't know who in this audience is a potential developer, but we would certainly love your input if you're interested.
Yeah, thanks, Chris. And I think that was actually a fairly beautiful segue into this as well, because these are some of the things that Chris and I just talked about, right? But how do we continue to build and refine the community? How do we increase committer diversity across the projects, code quality, coverage, these types of things? These are good, but even beyond the code committers, I mean, how do we get people that are interested in testing, or how do we get people that are interested in just joining the community on the IRC channels or the mailing lists and participating? These are all things which we're definitely interested in doing, is growing this going forward. On the staffing side of things, I think release engineering and documentation, Chris alluded to this earlier, but these are things that are in an open source project are sometimes the more challenging things to find people to work on. These two items here, documentation in particular, a lot of engineers are really good at writing software and maybe really bad at writing documentation for a variety of reasons. And a lot of the times that reason comes down to, we're writing code right up until the end, and we always push documentation until the very end. So certainly finding some people that can contribute by doing documentation would be great, because that's a incredibly helpful and useful way to join the community and be able to contribute if you'd like to as well. Certainly the engineering systems, how do we continue to refine those? The Linux Foundation is certainly helping there. I know that the CI infrastructure is currently on the move to a public cloud provider somewhere, so we can scale it in much the same ways that the OpenStack project does things. And that's going to be a huge win, I think, especially as the number of projects grows, the amount of testing that we do grows. The matrix gets big fairly quick, and so being able to kind of elastically expand that by using like a public cloud provider is going to really help us there as well. And then the last bullet is kind of one of Dave's favorite things as well. How we need more code that writes code as well. MDSal is an example. How can we get fewer humans in the loop and automate things? More automation is always better. Certainly for all of these engineering systems, that's kind of the way forward, I think.
Yeah, that's probably near and dear to your heart, Kyle, as Neutron PTL, where the OpenStack project has done a phenomenal job of building a continuous integration system, and it's arguably one of the strongest components of the OpenStack project, and this is something that we aspire to work towards in OpenDaylight as well.
Yes, absolutely, and it's actually been great to see, and the collaboration amongst the two projects in various areas is really something interesting to watch, because I'm not, and it's possible there's other systems, but OpenDaylight and OpenStack may be two of the projects that kind of cross-test each other to some extent, because the OpenDaylight CI runs on the OpenStack side, testing OpenStack changes that are merged upstream, and then on the OpenDaylight side, I believe we're now also running some of the same Tempest tests from OpenStack on OpenDaylight commits to ensure we don't break things that way. So it's actually an interesting, that's an interesting thing to me as well. We may be one of the only projects doing something like that. So this is just kind of a very high level. I think Lithium is far enough out in the future that we have a target release date, a plan is being worked on, but really Helium I think is where all the focus is right now. So this is just kind of showing you that we're looking beyond Helium a bit now and starting to think about that at this point. But it's too early really to talk in detail about Lithium, I think. Although we do have this plan here. But.
Yeah, I was going to say the main thing that we're doing is taking our learnings from helium and hydrogen and applying that to the release plan, and recognizing where are there things that we need to schedule differently in the release, or where are there things that we need to be either clearer about or more proactively engaging each individual project so that they understand the implications of, for example, we want to do stable releases. Well, you need to make sure you have a stable release container for your project.
And so this, right, and so this is kind of another eye chart slide that we won't go into detail here, but this is just to show that there is a plan that's being formed around this release at this point. So I think we've kind of reached the point where we're kind of at the end of the presentation here. So we'll kind of close with the formal slides here and say we'd like to see more people get involved. So hopefully we've inspired some people to learn more about OpenDaylight, to go and check out the wiki, the website, maybe download things, jump on IRC, join an email list or something like that. The weekly technical steering committee call is open to everybody, so that's on the wiki as well. You should be able to find that if you'd like to join in and see what a typical ODL TSC call is like. But certainly, getting involved is great, and like I said, there's many different ways to get involved and to help contribute and to kind of join the community. So I guess with that, we'd like to open it up for questions from anyone.
Well, Carl and Chris, thank you very much indeed. Just going back, I suppose, a couple of steps where you were mentioning the continuous integration that what's it called? OpenStack have sort of latched onto, and that using that as a possible sort of template moving forward. In terms of community and establishing a community, do you think that maybe there are existing examples of technical communities that perhaps you could, in a similar vein, look to for sort of for inspiration and direction, maybe to try and build up the OpenDaylight community?
Well, there's some analogs between OpenStack and OpenDaylight in terms of our structure. So one of the OpenStack projects is the infrastructure project. The infrastructure project is responsible for running the infrastructure, which includes the continuous integration pieces. We have a project in OpenDaylight called the integration project, conceptually very similar to the infrastructure project. And one of the things that we're looking at is actually using some of the same tools that are available for and built by the OpenStack community, and applying them to our infrastructure. So there's a tool called Zool, which allows you to essentially parallelize a set of integration tests across a series of commits, so that you could, say, commit 10 changes to your source code repository, via Garrett, Jenkins can kick off an integration test for each one of those individual commits in parallel, and Zool is the tool that kind of manages that and recognizes if there's a failure. It can just go ahead and kill off the subsequent jobs, or if everything completes together, then you didn't have to go through the heavyweight cost of serializing each of those 10 different builds and tests. So definitely, and in fact, we have people who are on the OpenDaylight side that are sort of maybe not day-to-day involved in the infrastructure project in OpenStack, but at least monitoring it and trying to take cool ideas and apply those across to OpenDaylight. Hopefully that answers your question.
Yeah, it's yeah, that pretty much does. Okay, any more questions from anyone still on call? Not had anything come in yet. You've obviously been dazzling people with what I have to say was yeah, quite a veritable mountain of information in there. I had no idea it actually went that far, and there were so many different products in there. I mean, obviously you've both been involved in this for quite some time. I mean, for someone who is perhaps new to OpenDaylight, I mean, is it difficult to get to grips with in terms of the architecture, all the dependencies and the various projects, and getting up to speed with what's required? Is it quite a steep learning curve, do you think?
So I'll take a crack at that first, Chris. I think it kind of depends on what your level of integration and your learning, where you're comfortable with things. If you're interested in trying it out from a user perspective, where you're interested in something like the OpenStack integration, I think that's a fairly straightforward thing for someone who's familiar with those types, with OpenStack, with networking in general, things like that, especially with how OpenStack networking works. I think that's easy. If you're interested in writing an application on top, again, we have APIs that are published that you can look at for how you would like to integrate from a REST API perspective into OpenDaylight. And I think, the third thing is, are you interested in contributing back to the project? And I think that'll depend on if you have experience writing code, whether that's Java or some other object-oriented language like C# or Python or something like that, you can probably jump in and take a look at that and certainly jump onto the IRC channels and ask questions there, or the mailing list. So I think it really depends on where you want to jump in and what your skill level is, but hopefully there's enough areas to get on board where people of varying levels of skill and interest can all get on and try things out.
Excellent. Right, I'm not sure if we've got any more questions from anyone at all. If not, then I'll let Carl and Chris go about their days. Hopefully, we're hoping to have them back at some point later in the year. I think possibly we're looking at sort of October, November time, possibly to go into a little bit more depth into some of the maybe some of the architecture or some of the separate products that form part of OpenDaylight. No more questions come in, so going to wrap it up now, I think. But Carl and Chris, thank you very much indeed. It's been very, very interesting indeed, and we look forward to having you back.
Perfect. Thank you for the opportunity.
Yeah,
Thank you very much indeed.
Okay.
Cheers. Bye.
Yep.